Here's problem 3041. A long wire carries a current of 3 amps along the axis of a long solenoid, raised 3 centimeters, 900 turns per meter, current of 30 milliamps. What is the magnitude of the magnetic field at a point 2 centimeters from the axis of the solenoid? Neglect any N effects. So let's say we had a wire carrying a current. And the current in that wire is 3 amps. And because that wire is carrying a current, there will be a magnetic field by the right-hand rule going around this direction, around that wire. Sounds good. And that magnetic field will be equal to mu naught I over 2 pi r, wherever your r happens to be. We're going to put this whole thing inside a solenoid. And because we're running current down through the solenoid, there will be a magnetic field through the center of this solenoid equal to mu naught little n current of the solenoid. And hence, we're going to end up with two magnetic fields that are going to be perpendicular to one another. The solenoid current is parallel to the wire, but the current, the wire's magnetic field is going to be circularly around it, so that's going to be perpendicular to the axis of the solenoid. So they're going to be perpendicular to each other. So the magnetic field of the solenoid is going to be mu naught little n current of the solenoid, which is going to be 4 pi times 10 to the minus 7 times the number of turns per length, which is 900 turns per meter, and then the current of the solenoid is 30 milliamps, 30 times 10 to the minus 3. So this is equal to 3.39 times 10 to the minus 5 Tesla, and they'll be directed along the axis of the solenoid. On the other hand, the magnetic field of the wire is going to be mu naught I over 2 pi r, and that's going to be 4 pi times 10 to the minus 7 for mu naught. Current of the wire is 3 amps over 2 pi, and then we're going to evaluate this 2 centimeters from the axis of the solenoid, which is the axis of the wire, and that's going to be 2 times 10 to the minus 2 then for that distance. 4 pi divided by 2 pi is going to leave us with a 2, and that 2 will cancel with this 2 down here. So this is going to be 3 times 10 to the minus 5 Tesla, and it is going to be going circularly around. It's going to be perpendicular to the axis of the solenoid itself. So we're going to end up with two magnetic fields. One of them is 3 times 10 to the minus 5, and the other one is 3.39 times 10 to the minus 5, and they are perpendicular to one another. We want to find the magnitude of the net magnetic field. So the magnitude of this net magnetic field is going to be equal to 3 squared plus 3.39 squared, all that square root, times 10 to the minus 5. And that is equal to 4.53 times 10 to the minus 5 Tesla, or if you will, 45.3 microtesla is the magnitude of the magnetic field that exists at that point 2 centimeters off the axis of the solenoid.